Okay, we're going to solve a 3 by 3 system. Look at the system and decide which variable you'd like to remove first. Usually you pick the easiest one. In this case, I see that if I add a to c, equation a to c, then these x's will disappear because they'll cancel out. So that's what I do. I add a to c in order to remove the x. Now, this gives me another equation, d. Came from adding a to c. Notice that y and 8y is 9y, z and negative 3z is negative 2z, negative 10 and negative 5 is negative 15. Now I have to decide again, I'm going to repeat that step and try to remove x again, the same variable x again, from a different combination of equations. This time I'm going to work with a and b, but in order to make that x disappear, I have to make this coefficient up here into a negative 2. So I have to multiply equation a by a negative 2 to make that negative 2. So then I'll add it to b. That's my plan. Now here's the equation a multiplied by negative 2. Here it is. Here's the equation b. I write it underneath, and then I add. Notice that not only did the x's drop out, but the z's also, coincidentally. So here's my new system. It's 2 by 2. I've reduced a 3 by 3 into a 2 by 2. This has y and z. And now I notice that, well, I might as well use the substitution method because the second equation is very easily solved for y, and I'm that much closer to my solution. Once you have that, you back substitute into the same system. Okay, this time I'm going to use d because it contains the variable that I need, z. So I substitute in, solve for z. Those are the details. Then I take both of these numbers, y and z, and I put those back into one of the 3 original equations because I need to get x, and it's those 3 equations that contain the x. So I pick equation a to do that from the original system and put in my y and z values, simplify down, solve for x. X is equal to negative 1. I write my solution in ordered triple form, negative 1, negative 3, negative 6. And of course you should check your solution in the original 3 equations, the original system.